This video is on radioactivity. Not all nuclei are stable. Unstable nuclei get to more stable states by a process called radioactivity. This process is totally random and we cannot change it, by example with heat and pressure. There are three ways this can happen. The first way is by alpha decay. We have the nucleus on the left and the alpha particle on the right. As the alpha particle has 2 protons and 2 neutrons, this means that the A number of the nucleus goes down by 4 and the Z number of the nucleus goes down by 2. The second way is via beta minus decay. This happens when there are too many neutrons compared to protons in the nucleus, and so a neutron changes to a proton and an electron is released. A number stays the same, but Z number goes up by 1. There is 1 extra proton in the nucleus. The final way is via gamma decay. In this case, an electromagnetic wave is released from the nucleus. This is a high energy wave with no mass. Both the Z and A number of the nucleus stays the same, as no nucleons, protons and neutrons are changed or decay. Now let's look at some example questions. Example 1. The below nuclear equation is the alpha decay of radon to polonium. We need to state the Z and A numbers for polonium. A number equals 222 minus 4 equals 218, and Z number equals 86 minus 2 equals 84. Remember, in radioactive decay, the atomic Z numbers and mass A numbers balance on both sides of the nuclear equation. Example question 2. Identify what particle is in the question mark in the following nuclear equation and state the type of decay here. It is an electron and it is beta decay involved, as the number of protons increases by 1 after decay. Now on to the final part of this video, which is on ionizing and penetrating power of radioactive particles. Let's start off with ionization. This simply is when an electron is knocked away from an atom by collision with a particle such as a gamma ray. Alpha particle, slow and massive, so tend to be highly ionizing to atoms. Beta particle, moderately fast but smaller than alpha particles, so tend to have medium ionizing power. Gamma rays, fast and tiny, and so tend to go straight through the atom and are very weakly ionizing. Moving on to penetrating power. We will now watch an animation where we'll see an alpha particle, beta particle, and a gamma ray being fired against a sheet of paper, 5 mm thickness of aluminium, and 5 cm thickness of lead. As we just saw in the animation, alpha particles are stopped by the paper, beta particles can go through the paper but are stopped by 5 mm of aluminium, whereas you need 5 cm of lead to stop gamma rays. Also, alpha particles can be stopped by skin and gamma rays by concrete, but you need meters of thick concrete to be able to stop gamma rays. Let's now compare ionizing and penetrating power on a graph. So we have our two axes. Ionization power on the y-axis and penetration power on the x-axis. Alpha particle has high ionization power but low penetration power. Beta particle has medium ionization power and also medium penetration power. Gamma ray has low ionization power but high penetration power. Thank you very much for watching this video. Goodbye.